Hello, my name is Berkay. I will talk about my parts of project and I will explain my code. As you can see, we made a four-player Pong game. This Pong game being played by the algorithms that I wrote, so there's no real players, just different algorithms playing in each other. Okay, let me start then. Firstly, let's look data types. My vector2 class, I'm using them for calculating where my game objects in two-dimensional world. As you can see, there's x and y coordinates of them. There are some static methods for me to use them fastly because I need them very much. As you can see, vector2 up. Up means downside at pie chart. Vector2 up, down, left, right. As you can see, they're just directions. There is magnitude function for me to calculate magnitude of a vector and normalize function. As you can see, there is some addition, subtraction, multiplication, and blah blah blah, something like that. I need them because vector2 is a data type that wrote from me, and Python don't know how to multiply or how to add two vectors, so I have to define them one by one. And also sometimes I need translate my vector2 to tuple, so I wrote a tuple function in my vector2 data type. Also, there is my physics class. In physics class, I'm just calculating when a box collider and circle collider intersects, what will happen. Box collider is in my ball and no, box collider is in my pedals and circle collider is in my ball. As you know, in classic Pong, let me show, when a ball and pedal intersects, if they intersects from upside, ball goes upside. If they intersects from downside, ball goes downside. If they intersects from middle, ball goes middle. And I made my Pong due to classic Pong. That's where I made this gameplay mechanic. And there is my box collider and circle collider classes. They have their constructors. I will put them in my game objects. Let me show quickly. Yes, there are my entities. I developed the project due to object-oriented rules, as you can see. There's a game object, and every game object has a name, has a position, and has a shape in my system. And also every game object has a move function. As you can see, I'm putting a shape in every game object, and every game object has a velocity. At the beginning, all of them's velocity are 0, so I don't need to put them in constructor as an argument. There is my pedal class. A pedal also has a game object, and it takes its name, position, and shape from its superclass. But pedal also has direction, speed, and collider. As you can see, collider is coming from box collider 2D class. There are my functions of my pedal. As you can see, move right and move left. Move right and move left means local moves. As you can see in constructor, every pedal has a direction. In my Pong, let me show it again. There are two type of pedals, horizontal pedals and vertical pedals. When I initialize the pedals, if I give the direction, for example, to red pedal, I give its direction to up. This make if it's your direction is up, when I said you go right, you actually going up. When I said move left, you're actually going down. But it's calculating the movements to the local direction thanks to my direction in constructor. There is also a stop function for every game pedal. There is an earned score method. Every pedal has a score inside of self. When they win a score, I will call that function. And also there is a stay in area function. I don't want my pedal goes to outside of the screen, so I put that function and call it when it's necessary. There is my ball class. It's again a game object. There is something named owner. What that means, let me show it quickly. As you can see, ball was black, but when some pedal hit it, ball takes its color. And when it's been a goal, as you can see, it's just look in. As you can see, it was green when blue pedal can't reach it. So green one wins a score. I put an owner for being able to do that. When a ball goes to keeper and keeper can't touch it, ball look who is my owner, who has to win score, looks that owner. Owner will be a as you can see in here on hit pedal. When a ball hit a pedal, I make owner of the ball that pedal. And also when the ball hit a border means that's long fence. In Turkish they're kale. When ball hits them, and looking is owner, and owner earns score. That's a basic concept, but I think it's working properly. And there's my border class. It's again a game object. It has a box collider again because I need to detect the collisions. And there is scoreboards game object. They are just these number friends, and all of them has a draw function inside of them, as you can see. There is my also shape class. I want to show it. Again, I made these friends due to object oriented. There's a shape class. Anyway, every shape has a screen and a color because I need to know where I'm going to draw this screen. I will put them in the main script. And also my circle, rectangular, and text classes, which is inherited from the shape and their draw function inside of themselves. That's all actually. Let's look at the main class. Main script. I define some colors for being able to use. Here's my screen adjustments. Screen size, half size, what will be the screen's color, and bottom left, bottom right, the vertexes. My game settings, what will be my FPS, my game title, and blah blah. They are more important stats because I will play them as I want, as you can see in the default IR like this. But if I make this 100, I can change all the game just like this. I can do that also for pedals and pedal speed and ball speed and blah blah blah. As you can see, there is my main function, which I called for game being played. These friends are just calling one-time functions. I'm initializing game objects in this function. As you can see, I'm creating my objects, putting the informations on their constructor arguments. You need to initialize all the game objects just once. But in a while loop, I have to draw them positions again and again because my game objects are moving, so I have to draw them in every frame. And also my other important function is update, because update is calling in while loop as long as game is being played. My all important functions in update is moving game objects, handling collisions, handling points, and something. Let me show others. There's where I initialize the ball. After I initialize the ball, I'm giving them a speed in random from coming my vector2 class. There is where I'm trying to detect collisions. As I showed, collision detection is coming from physics class. I'm updating scores for every pedal. In every frame, I'm checking is this pedal win a score. If it wins, I'm updating its score on text board. I'm handling also points. When a collision is happened, let me remember what I did in here. Physics plus collider to the intersects. Yes, when a ball and a border means kale, is intersects, it means someone win a point. I'm detecting it in this function. I'm moving my game objects in here. As I showed, every game object has a move function in itself. I'm calling its move function, for example, in here for ball.velocity. I'm doing that in this function. This is my handle events function. What it does actually is just doing is event type pg.quit. Pg.quit means just this Çarpı button. It makes when I click on it is running false, and is running was making my infinite while loop. When it breaks, game is stop. Let me show this is running on my main function. As you can see, if it falls, game is stop. This is where I draw my game objects. It's being called in updates, and I'm drawing my objects in every frame. This is where I keep my pedals in area again. I'm calling the stay area function as I showed, and I'm putting the necessary values inside of them. There is some mathematics is here. I don't want to explain all, but it works. Here is the important part actually, because as I said, every pedal working with a different algorithm. They are not playing Pong with the same tactics. Where I put that tactics is in here. Here is very hard-coded parts of the project. As you can see, working logic of pedals is in here and it is very complex. There is also so many mathematical calculations in here, but let me explain very basically. For example, this green pedal is waiting ball to coming from his half side. When it goes out of the half side, it's just going to middle and waiting for the ball to come. As you can see, it's not moving. When it comes from here, it starts moving. But if you look at the white pedal, it's always following the ball. They're playing with different tactics, it's mean. And also every pedal has a target. As you can see, when a ball coming, white pedal taking blue and red friends as targets. It's not sending ball to the upper direction. It's his tactics where I code in here. Every 4 pedal playing Pong with different tactics. Actually, we are trying to detect which algorithm, which pedal's tactic is best for playing Pong. As you can see, it's also impossible to explain here in a short time. So I'm just showing and passing. Here's another important part, because my friends Furkan and Serhat are making a data virtualization due to game datas. Thanks to that function, I'm pressing an output in a JSON format for them. I'm simulating game many times and giving them a JSON file to make data virtualization. Let me show the datas that I will give Serhat and Furkan. Just a second. Yes. As you can see, I played the game so many times, actually 250 times, with different circumstances. Different circumstances means, for example, one circumstance is this default, and as I showed, I'm making ball so big, I'm making pedals so small, and let's play like them. This is a different circumstances, and maybe one of different algorithm will be better in these circumstances. That's what I made. That's all, actually.
In this section, we use Python data visualization technology. We have already imported our necessary libraries. And we got the result of game in JSON file formats. And in this line, we are uploading our data from JSON file as a dictionary. In the first parts here, we have a P cards. We analyze the first game results as a P cards, and here is the results. In the last part, we analyzed result of entire game in a line graph. Here is the result.
We created a presentation to analyze graphs. As you can see, when we reduce the size of the ball, the green algorithm works more advantageously. Red algorithm is very successful when pedal sizes are larger. If the speed of the ball is slower than the pedal, the white algorithm is more successful. Blue algorithm is best when the game is more stable. When we reduce the size of the pedals and increase of the speed, the algorithm works close to each other. When the game settings default, blue is the winner of game 1. When we reduce the size of the ball, the green algorithm works more advantageously. In this game, we shortened the length of the pedal and increased its speed, and the game turned more in favor of red. This made the game fairer, and the scores of the algorithm approached each other in the settings. In this game again, blue pedal algorithm is better than others. Although the blue pedal algorithm failed in the last games, it is the most successful algorithm when we look at the total score. These are total scores, and that is the graph.